Hello everyone, how's it going? So today we are trying to develop a motion detection system running on the server, on a web server running with Flask. So it's something you can always log in, remotely try to see what's going on your webcam. So it's like basically developing a remote monitoring CCTV camera system where you can monitor your feed over the web. So let's see how we can develop this. This is basically based on background subtraction. So it's just differentiating the foreground with the background. So let me open up a file, and this is basically the previous video in the series where we did smile detection, and this is the same folder, same project folder. I think we won't be needing these two files. These are the Haar Cascade smile and face detection. We're not going to do any face detection or smile detection, so we can simply delete them. And we'll be making all the changes in this camera.py file. But before we make those changes, I want to show you what background subtraction is and what kind of a background subtraction we are trying to do here. So we'll make a new file and we'll call it as motion.py, and let's open this in the text editor, and let me open up the editor here and come back. Okay, so let's see if I can make it a little bigger for you. Okay, that's it. Now let's import CV2. So you're using OpenCV, of course. Also use NumPy because we're going to do some sort of addition, subtraction, and some sort of calculations. So NumPy helps us in that matrix manipulation. Now the first thing you want to do is basically read your webcam, right? So you want to do capture. Let's create a capture variable. Cap is equal to CV2 video capture. And you want to read your webcam, which is at 0, and you're basically just reading it. And let's open up a while loop. Let's say while cap or while true is also fine, and we just say frame or success flag. This is just to see whether the frame is going to be read properly or not, and we'll call frame equal to capture.read. So this is just basically reading the image from the video camera and storing it into the variable called frame. Once we have the frame variable, let's display it on our webcam. So the way we can do it is by CV2 IMShow and or original frame, comma frame. So we're just displaying it right now. We do need the CV2 wait key function, because without that the OpenCV IMShow function will not work. But before we do that, since it's going to be a continuous loop, we do want the wait key function to refresh every time, and for that purpose we'll use a key, and we'll tell the key is wait key function and also any keyboard presses, and that'll be given by 0SSF. And if key equal to 27, which is nothing but the escape button, it should come out of the loop. It should break the while loop, and once the while loop is broken, it should release the capture. So my webcam is released and I can use that for other functions. And I also need to destroy all the windows. So destroy all the windows. That's it. So right now we are doing nothing but just reading the frame and displaying it on our webcam. So let's do that. Let's play this and let's open our command prompt. And where is our command prompt here? Okay, so I got the command prompt, and this is nothing but just the command prompt. Now let's open the file motion.py, and it should open up a webcam folder for us. Okay, so we have this frame coming up here. So right now it's doing nothing but just reading the frame out of the webcam and displaying it onto the window for us. So let's press the escape button. It has closed. Let's go back to the code. Okay, now we need to do a little bit of processing. The first step is to create a background subtraction system, and for that purpose there is a function called OpenCV create background subtractor. So it goes by this way. So you create a foreground or a background image or a foreground subtractor, and it's called as create background subtractor. So this is the function, and this function is responsible. This is an algorithm. OpenCV already has all the functionalities of this algorithm present in it, and we are just using the function as it is. So it creates this background subtractor, and it's able to perform foreground and background subtraction for us without doing those complex complications for us. So it takes care of all the backend subtraction and then just gives us the difference between the foreground and the background. So it's a very nice feature to add, and you can give some parameters, some threshold parameters. I noticed if I give the 300 by 400, this is nothing but the threshold value for my webcam, and you can always change these values as per your needs. And I can also monitor whether or not I need to check for shadows. So if I put true, it will look for shadows. If I put false, it will not look for shadows. And this is nothing but just the threshold value beyond which, it's nothing but just clearing the noise level in your image. So how much noise you're okay with, how much noise you don't want. So that's all what it is doing, and nothing much. So once we have this foreground background subtraction created, next step is just to calculate all the foreground image that comes out. So what you do is, when this step where we are reading the frame image, we will supply this frame image to this guy, the foreground background subtractor. And the way you do that is by creating a mask. So it will create a foreground mask for us, and and the way you do that is by supplying this image to the foreground background subtractor. And you say foreground from fgbg.apply, and you just supply the image frame. So once the frame is supplied, and you can just simply maybe try to display it right now. I am show for FGBG image, and we'll say F foreground mask. So this is just nothing but creating displaying that foreground mask for us. So let's save this, and I'm going to change it to the other webcam which I have on the computer, and I'll put down 1. And if you have only one webcam connected to your computer, you can always put down 0. But since I have 2 webcams, I'm just using the other webcam to display this. So it doesn't matter whatever webcam you use, it should work the same way. And we just display motion, python.motion. We just run this code, and let's see what the output is. It's taking a little longer than we had expected. Maybe my webcam is busy and it's not able to read the frame, but let's see what's going on. Let me close this thing. Let's change the webcam back here. Let me go back to 0 and see. I thought this webcam would cause problems, but it looks like my main webcam is causing problems, but doesn't matter. Okay, so let's run python.motion. So nothing is running. So there is an issue. It looks like CV2 has no attribute create background subtractor. So we did some sort of a typo for sure. Let's go back here. Let's see what kind of an issue. Oh yeah, we did not supply what kind of a background subtractor it is. So of course you're creating the background subtractor, but OpenCV has different types of background subtractor, and the one which we are using is called as MOG2. And let's save that. Let's open our command prompt back again, and let's run this. So let's see how this one works this time. Hopefully we don't run into any issues. Oh, it looks like it is running. Okay, I got the original frame, and I got the foreground mask as well. So we can see that it's able to display my original frame in this particular window, and I already have the foreground background present here. So if I stay still, you can see that the screen is getting black, and that means that there is no mask creation. But if I move, you can see this mask has been created. But if I stay still in that area, then it becomes black again, because now I'm blending with the background. It thinks that I am the background. So that's what because you're not saving your background image. You're while the program is running, you're calculating your background on the fly. So that's the reason it's always updating the background at every instant. And this is very helpful in motion detection. Whenever you're creating motions, it'll create that mask for us. Now let's take that information and put it on our web server. So I'll press the escape button. I'll close this thing. Let's clear this guy for us. So that's it. Now coming down to our main file. So we have this camera.py main.py. Motion.py is nothing but the file which we just created, and it's nothing to do with the server. So don't worry about motion.py. We'll open the camera.py file, however, and let's open this camera.py file, and we have it up here. So coming down to this file. Yeah. So this is the camera.py file, which is coming from the smile detection video, which is just before that, and I will leave the link in the description. So this is the third video in that series. So if you have not seen the previous videos, do go ahead and at least watch the first video, so that'll give you an idea of how to set up the web server, of how to display the images on the web server, and if that's something of what you're looking for. So let me minimize this a little bit so you can see what's happening here. So here on the first two lines here, this is more about that face detection and smile detection that we were doing in the previous videos. But since we are not interested in doing face detection in this video, we'll just delete that. In fact, this whole code where we are just calculating the face profiles, the smile detection profiles, everything is of no interest to us. Right now, we're just having the simple code where it's just reading the video from our video capture file and displaying it on our web server. So that's all the code is doing right now. But let's now make it where it can make those, where it can calculate those foreground background subtraction and then display whether or not there was any kind of motion in the program. Now let's come back and import NumPy, because we do need NumPy for some addition and subtraction. We'll do import NumPy as NP, and we will create, now go back to the motion.py file, see what are the things that we initialized. Let's take this guy. We need this FGBG create background subtractor, and we will paste this. Let me maximize this a little bit, so now that way it's easier for you to read. So we have FGBG create background subtractor MOG2. Now this guy is initialized, and we just need to calculate what the foreground background is going to be. So we have the frame, and we simply create the foreground mask that like we did it in the previous program. In this program, we just going to copy the same step here. So we have this FGBG dot apply frame, and we just copy that. We come back here and we say FGBG apply dot apply, and this is just going to create that mask for us. Now once this mask is created, the next step we want to do is count the number of pixels that are present in this mask. So we can find out how many pixels are actually present in this mask, and every time there is a motion, the amount of pixels, the amount of white pixels in the image increases, and we'll use that as our indication of motion. So how are we going to detect that motion? And the way we can do that is by calculating the number of pixels, and if the pixels are beyond a certain value, then you know that there is a motion. So we'll say count equal to np.count, and let's count all the non-zero pixels, all the non-zero values, and that's nothing but the white pixels, because the black pixels are nothing but zeros. So white pixels are a combination of 255, 255, and 255. So all the non-zero variables, just count them from the FG mask and store them in the count variable. And if the count variable is greater than a certain value, let's say 5,000, just for the sake of it, or in any value, whatever you feel, just try it out and see which one works out for you. So if count is greater than 5,000, then let's put down a text on the image. We put down CV2, put text, and we put it on the main frame, and this is the frame, and we'll say motion detected. Okay, we'll say, the moment there is a motion, we'll say motion detected, and we will put it down on value 1070. So this is nothing but the place where I want to put that frame. And once we have this set up, we want to make sure what kind of font you're using for this thing. So let's put down CV2, or let's put the comma. Let me not forget the comma. Okay, comma, and then CV2 font. And OpenCV has this default font, Hershey Hershey Simplex. It's easy to remember for me. So it's Simplex. It has other fonts as well, but we're just using this font. And the color is going to be 255, so it's going to be red color, and the thickness is going to be, say, 3. And we just close this. Okay, so that's all. We're just writing the text, the motion detected, on the frame, and it's going to be writing down at this location 1070. This is nothing but the coordinate of where the text is going to be written, and that's the font it's going to use, the color. Oops, why is it jumping around this way? And this is going to be the color, and this is going to be the thickness. Thickness is 3. Oh, did I not put the font here? Yeah, I do need to put the font size as well. So we'll say the font size is 2 and the thickness is 3. So yep, we come back here, and that's how that's the whole code. That's all the camera.py code is going to be for. And we just save this, and we open up our command prompt again, and now we run the main.py file, because the main.py file is in this particular folder. The main.py file, this is the main guy which runs the server. So that's why we're going to be running python main.py, and it is running, and it's running on this localhost 5001. That's the port address. And let me open up my browser, and it's taking a few seconds to open up. It's still loading. I don't have the fastest computer, so bear with me. While it's loading, let me know how you guys feel about this project, and if the web server series is helping you out or not. Give me any kind of feedback, what you would like to do, what you don't like to do. That way it helps me create my projects for you guys. And localhost 5001. Oops, yeah, let me bring the browser here. Localhost 5001, and not without the exclamation. And let's run this. So it's still showing smile detection, and because it's the original code for the smile detection, we'll change that in a bit. But you can see if I move, it's detecting motion. And if I stay still in one place without doing much, it's not detecting any motion. The moment I move, it's going to say motion detected. Come back again, motion detected. And motion detected. So that's how it's working. Let's try to change the smile detection. Come back to our folder, and we can go into the templates folder and open this with the editor. And instead of smile detection, we're going to say motion detection as well, and save this. Come back to our browser, and let's just refresh this, and it has now changed to motion detected. So you can see it's doing motion detection for us. So that's what the code is about. That's what we're trying to achieve here. So you can see that it's easily and very nicely able to detect motions. So if it's something, if this project is helping you, and if it's something you want to do, and it's this is the field that you're trying to do consider subscribing. Leave us a like, subscribe to the channel to follow along our journey. Our motto is to keep learning, keep growing. With that, you guys take care, stay safe, bye bye.